Alright, this is day 3 in unit 3, and we're doing example 3 for polynomials. Alright, so it says, given the equation, use your knowledge of factors, roots, multiplicities to sketch a possible graph of each polynomial below. So first off, we need to figure out what are the x-intercepts based on the factors. So to do that, we set each of them equal to 0 to figure out our x-intercepts. So I know one of my x-intercepts is at -2. Setting the other one equal to 0, I know one of my other intercepts is that x equals 3/2. And then the last one set equal to 0, x is equal to -1. So I'm going to put a dot at -1, a dot at -2, and 1 at 1.5, because 3/2 is 1.5. It's right in between 1 and 2. Alright. So now we're going to use our equation to help with the graphing. Because of the negative in the front, I know that my graph should be going down on this side. So I'm going to start from the right hand side and go backwards because it's actually easier to graph that way. At -1, or at that root, I'm supposed to have, at that root, this is the 2x minus 3, so this is the 1.5. My exponent is a 2, so that means I should be bouncing. So I'm going to come up to the root and bounce down. So I know at 1.5 I should be bouncing based on the multiplicity or the exponent. Then at -1 I'm supposed to have an exponent of 3, which means I'm doing the swivel. So I'm going to swivel through at -1, and then at -2 I have to come through and go straight through it. So you're just getting an approximation of what your graph looks like using the roots and then the multiplicity at each root. And you can go back and check. At root 1.5, my exponent was 2, so it should be a bounce. At root -1, my exponent was 3, so it should be a swivel. And at root -2, my exponent was 1, so it's going through it, straight through it. And it's a negative to start with, so I'm ending towards the negatives. Let's try the next example. So here again, set them equal to 0 and solve. So my first x-intercept or root is x equals 3. My next x-intercept or root is x equals -1/3. And the last one is x equals -1. So I'm going to put my roots onto my graph. I have -1, +3, and then -1/3 is -0.333, so it's closer to the origin. Alright, so same thing. This is a positive because there's no negative in the front, so I'm going to be ending up. At +3, my root is 1, so I'm going to go straight through at +3. At -1/3, it's also going straight through, so I'm going to go straight through. And then at -1, it bounces, so I have to come up and then bounce down. And then here's the approximation of my graph. It's positive. As x approaches infinity, f of x is positive. At root 3, it's going straight through. It's a multiplicity of 1. At root 1/3, -1/3, the multiplicity is going through, so it's an exponent of 1. And then at -1, it's bouncing, so it's a multiplicity of 2. Example 4 will be next. So let's take a look at example 4. Here it's giving you it's asking for the sketch given the zeros and the multiplicities. So for letter B, it's saying your zeros are 2 and 4. So I'm going to put dots at 2 and 4, or points at 2 and 4, with a multiplicity of 1 and 3 respectively. And here, let's include that as x approaches infinity, f of x approaches positive infinity. This way we know if I'm ending up or if I'm ending down. So at 0, or excuse me, at 2, my multiplicity was 1, and at 3, my multiplicity, at 4, my multiplicity was 3. So since I'm ending positively, I know I have to come up. So I want to do that little swivel, and then come back and go straight through. So there's the best estimation of my graph. I have a swivel at 4 for the multiplicity of 3, and I go straight through at 1, at 2 for the multiplicity of 1. For the next one, I've got 3 zeros, and this one, let's say as x approaches infinity, f of x approaches negative infinity. So let me plot my points. I have negative 6. Put a dot there, negative 1/2, positive 3. All right, at 3, it says the multiplicity respectively with 3 is 3, and I know I'm ending down, so I'm going to swivel pointing down. Then at negative 1/2, my multiplicity was 1, so that means I go straight through it. And then at negative 6, I have to bounce. So there's the best approximation of my graph. At the 0, 3, I have a multiplicity of 3. At the 0, negative 1/2, I have a multiplicity of 1. And at the 0, negative 6, I have a multiplicity of 2 with the bounce.